Uh, Good morning, everybody. This is a clarification video for orbital overlap and chemical bonding. So you have already done the FAIR simulation, and what you have got. I ask you to do neon-neon interaction and also to study oxygen-oxygen interaction. And what you got, this is your zero line, and this is when you are going here, this is positive energy. When you are going there, this is negative energy. So what does it mean? How we get positive, positive? So positive, positive means the interaction between nucleus and nucleus, and this is repulsive. In the same way, interaction between electron and electron will give a positive value. This is also repulsive. So repulsive forces are positive. So when you are going up from the zero line, that means your repulsive forces is increasing. And when you are going down, the interaction is between nucleus and electron or electron and nucleus, right? So this will give you negative value, and this negative value is attractive forces, right? Or E minus. So that's why when you are going from 0 to down, this is your attractive forces, right? So now let's have a closer look. So this is here one neon atom, this is another neon atom. So they have overlap, right? There is considerable amount of overlapping. And when you have the overlapping, you can see here more clearly, this is one nucleus, this is another nucleus, right? And you have sandwich electrons between the nucleus, right? Between the nucleus. And these sandwich electrons are attracted by both nucleus, right? And you see the electrons of left atom has penetrated the orbitals of the second atom, and this atom has penetrated the orbital of this atom, right? So and this drawing you have attractive forces between electron, nucleus and electron, nucleus and electron, right? So when orbital overlaps, what happens? You have sandwich electrons, and the sandwich electrons are attracted by both nucleus, right? Both nuclei. And so this means the sandwich electrons, in another way you can see that they have penetrated the orbital of other atom, right? So this orbital penetration will increase your effective nuclear charge, and this will also give you high nuclear pool, right? High nuclear pool. And because of the high nuclear pool, that means you have a lot of attractive forces, Fa, and your Fa is much more higher than the repulsive forces, Fr. And since attractive forces is negative and repulsive forces are positive, so you are getting, the drastic decrease in energy, right? And you have also observed when you put the atoms here, they were oscillating, right? They are oscillating, coming back and forth, right? Coming back and forth. So this means this is the most stable position. Most stable position where you have the huge amount of attractive forces. And when you are going here, you have the atoms are so much close to each other that they have penetrated even the nucleus, right? You need nucleus, and this, because of this huge penetration, so nucleus and nucleus will repulse, and electrons will repulse, right? So positive, positive, negative, negative. So this will give you positive value, and this positive is nothing but the repulsive forces, right? So your repulsive forces are much more higher than the attractive forces, And because of this, you see here the electrons is kicked out. Sorry, the atoms are kicked out when you bring them too much close to each other. And what's happening here? So atoms are far away from each other. So that means they don't have so much attractive forces and so much repulsive forces. So in another we can say Fa is equal to Fr. That means attractive forces and repulsive forces are equal, and so to cancel each other you get the zero value, right? Okay, so now in case of oxygen, you also got the same thing right here. When you put the atoms in one of this position, they oscillate, they come back and forth. So this means this is the most stable position where you have significant overlapping between the orbitals. And because of this overlapping, you see these electrons and these electrons, right? They are between the two nuclei, and like this they are between the two nuclei. And so you have a lot of attractive forces between nucleus and electron, and electrons and nucleus, right? So that means you have huge amount of attractive forces, and this is much more greater than your repulsive forces, right? So in case of oxygen, you have to consider two things. Number one is your sandwich electrons, and number two is complete octet, right? So when one oxygen atom share with another oxygen atom, so there is sharing, and this is actually oxygen-oxygen covalent bonding, right? So oxygen-oxygen covalent bonding, and this has happened because you have complete octet and you have sandwich electrons. These collectively, you see, give you the penetrated electrons, right? Penetrated electrons are attracted by both nuclei. So these electrons are penetrated. So they are penetrated electrons. So because of this, you're going to have very high value of J, effective nuclear charge, right? And consequently, you are also going to have huge nuclear pool, right? Huge nuclear pool, and this collectively will give you much bigger value for attractive forces, Fa, right? Then repulsive forces, and because of this, the difference is so huge, you will have the drastic fall in energy, right? Here we have already explained here, right? Same thing is happening when the two atoms are very close to each other. We have a lot of repulsion between nucleus, 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 and electrons, electrons, right? So, so because of this repulsive forces, very high value of repulsive forces, so this is much more bigger than your attractive forces, and because of this, the atoms is kicked away, kicked out, right? And here your attractive force and repulsive force is equal, so they cancel each other. You are getting zero, right? You are getting zero when the atoms are away from each other. So I hope you have understood it. So this is the most favorable position when you have huge attractive forces for chemical bonding, right? Chemical bonding. So when you have a lot of attractive forces, bond will be met, right? And when you have a lot of repulsive forces, this one and this one, so bond will be bond broken, right? Bond broken because of huge amount of repulsive forces. So I think you have now understood the how chemical bond is made, right? How chemical bond is made and how chemical bonds are broken, right? So thank you so much. I hope everything is clear, right? Have a good day.